Hello everyone. Today we'll discuss the last topic of this module, that is time series input modeling. In the last class we have studied multivariate and time series input modeling. Multivariate we have already discussed, so I'll discuss today time series input modeling. What do you mean by this time series input modeling? A sequence of random variables, we need to generate the random variables, is said to be time series if and only if the x, that is the random variables, are identically distributed. Identically distributed is nothing but it is normally distributed. Okay, then random variables are dependent. In the previous session only we have discussed it is if it is dependent, then only we can just apply time series and multivariate input modeling. So random variable should be dependent and it should be normally distributed. Okay, in this case we take the covariance as xt and xt plus h. This is called as lag h autocovariance, and rho n is equals to correlation. This is CORR, means it is a correlation. xt comma xt plus h is called autocorrelation. Now what is this covariance? If the covariance depends only on the value of h here, if it depends only on value of h but not on t, then this time series is called covariance stationary. Okay, if it depends only on t other than h, then it is called as a covariance stationary. This covariance stationary time series are of two types. One is AR1 and EAR1 model. AR1 model means auto-regressive order 1 model. Then EAR1 model means it is exponential auto-regressive order 1 model. This ER1 model is given by xt, that is what? It is only dependent on t, not on h. Is it not? The random variable is equals to mu plus 5 of xt minus 1 minus mu plus epsilon t. T varies from 2, 3, 4, 5, 6 like that, where epsilon t are independent and identically distributed with mean 0 and variance sigma square epsilon, and phi is equals to rho and mu is equals to x bar. We already know mu is equals to x bar. This is the mean we calculate. EAR1 model is given by xt is equals to phi xt minus 1 with probability phi xt minus 1 plus epsilon t with probability t minus epsilon, where t is equals to 2, 3, 4, 5, 6. Then phi is equals to rho we have to consider. And you have to just remember when you have to apply AR1 model and when you have to apply EAR1 model. This EAR1 model works only if the correlation is greater than 0. That is only for positive values. After finding out the rho value, then you have to just check whether it is positive or negative. If it is positive, you have to go with EAR1 model. If it is negative, then you have to go with AR1 model. Okay, then let me go for the problem here. Consider the following inter-arrival time 1.95. These are all the 20 inter-arrival times they have given. Find an input model for this one. How you will find out the input model for this? With autocorrelation rho. Now let me come for the solution. Rho is equals to covariance of xt, xt plus 1 divided by sigma square. This covariance of xt, xt plus 1 is given by 1 divided by n minus 1 summation of xt plus 1 minus n minus 1 into x bar whole square. This is the formula to find out covariance. So covariance of xt, xt plus 1 is equals to 1 divided by 20. How you will take it as 20? You have to count all the inter-arrival times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 are there. So here I have taken 1 divided by 20 minus 1. Now the thing is how to take this sigma into sigma xt plus 1. We get the value 924.105, but how? How you have to get it? See, xt plus 1. See here, this is xt means this is xt plus 1. How I have to do is 1.95 into 1.75. You will get some value, that is 3.4115. Next again you have to consider this 1.75 as xt. xt plus 1 means the next variable, 1.75 into 1.58. 1.75 into 1.58. This is summation xt plus 1 calculation I am showing. Okay, then 1.58 into the next value, that is 1.42. You will get 2.765, here 1.8176. In the same way, 1.42 into 1.28, that is 1.8176. Then 1.28 into all the 20 numbers you have to take, that particular number and the next number. Then 1.15 into 1.64, 1.196, sorry, this is 1.04, 1.04 into 0.93, 0.9672, then 0.93 into 0.84. In this way, we have to just calculate the multiplication of all the numbers, the current number, next number, current number, next number, like that we have to just do all these things. Then if you sum all these things, you will get it as 924.105. Okay, this 924.104 I have to just update over here, 924.105. This is how you will calculate summation xt plus 1 minus n minus 1, it is 20 minus 1, x bar, already we have calculated x bar over here. You know, summation xi divided by n, all the numbers addition divided by the total number of numbers. Okay, so if you calculate, then the covariance of xt plus 1 value, I'll get it as 21.66. This is the covariance. Now next, if you want to just find out the autocorrelation rho, you need to find out the value sigma square, is it not? This one, what is the formula? Summation x square minus n x bar whole square. How will you find out this summation x square? In the last problem, already we have calculated x bar, then we have added all the values and then we got. But here, how will you do this? Here also the same thing. The very first number is 1.95. 1.95 into 1.95 plus this 1.75. 1.75 into 1.75 plus 1.58 into 1.58. Likewise, you have to just multiply all the numbers, then add the things, and then you will get this one. That is 1046.57. Are you getting? All these numbers, 1.95 into 1.95 plus 1.75 into 1.75 plus 1.58 into 1.58 plus 1.42 into 1.42 plus 1.28 into 1.28 plus 1.15 into 1.15. Likewise, till 9.2 into 9.2 you have to do. For that value, what you will get? That value you have to update. For that, I'll get sum as 1046.57 minus n means 20 x bar whole square. X bar already we have calculated 5.194. So 5.194 whole square divided by n minus 1, that is 20 minus 1. You'll get value as 26.68. Now we have covariance value also and sigma square value also. Now it is very easy to find out the autocorrelation rho. That is 21.66 divided by 26.68. Rho is equals to 0.811. Now you have to decide which model you have to use. Already I have told autocovariance is positive, which is greater than 0. You have to apply EAR1. So here I have told if rho value is positive, use EAR1 model. If it is negative, use EAR1 model. But here it is positive, so I'll use EAR1 model. It is given as xt 5 xt minus 1 with probability 5 xt minus 1 plus epsilon t with probability 1 minus 5. where phi is equals to rho. Rho value we have already got. Wherever you have phi, you just replace the value phi with 0.811. See here, in place of phi, 0.811 xt minus 1 with probability 0.811. 0.811 xt minus 1 plus epsilon t with probability 1 minus 0.811. You'll get it as 0.189. This is EAR1 model, and this is the complete problem for your time series input model. Okay, based on the positive or the negative correlation you are getting, you have to decide whether it is EAR1 or AR1 model. Okay, this completes this complete module. Fine, thank you.